Let's consider our sixth organic conversion. Sixth one, you can see we need to change only OH group with the hydrogen atom. Basically, we have to use few reactants and few steps to complete this organic conversion. Exactly, we have to use a Grignard reagent and a few other reactants to complete this one. First of all, I need to convert this OH group into a bromine or chlorine atom. For that I can use Br3. This reaction is a nucleophilic substitution reaction and the nucleophile is Br-. The resultant product of this step is just like this: OH substitute with bromine and both CH3 groups will not be changed in this circumstance. So this one is a nucleophilic substitution and the nucleophile is Br-. And after making this alkyl halide, we have to use magnesium and ether to make the Grignard reagent. As we have done previous organic conversions, we can have this Grignard reagent. Then our last step, we have to use some hydration reactions. In hydration reaction means we have to use H2O or dilute H2SO4 or dilute HCl for the hydration reaction. I use H2O or dilute hydrochloric acid. Then I can substitute hydrogen atom for this MgBr group. Now consider about our seventh organic conversion. In seventh one, we have to convert alkyl iodide into this alkane. Basically, when we consider about this alkane, this is an aromatic alkane. So we have to use Grignard reagent and hydration reactions as we have done in our sixth organic conversion. First of all, I need to make this Grignard reagent. Now you know how to make a Grignard reagent. We should have a alkyl halide, magnesium and dry ether. For this reaction, I use magnesium and ether as the reactants. After making this Grignard reagent, we have to use some hydration reaction. Then you can see this organic conversion comprises with two steps. So I have to use dilute H2SO4, or if you like, you can use dilute HCl or H2O. Exactly, this is our eighth organic conversion. In eighth organic conversion, we have to convert a primary alcohol into a secondary alcohol. Our primary alcohol in this circumstance, this can be named as propanol, and our resultant product can be named as 2-propanol. First of all, we have to make an alkene. For that, we have to use concentrated H2SO4 under 170 Celsius degree. Basically, this reaction becomes an elimination reaction. This is our alkene. This alkene is known as propene. This one is propene. After making propene, we have to use only another one step, that is, we have to add OH minus nucleophile into the middle carbon atom. To convert this propene into the secondary alcohol, we have two options. First one is we can use dilute sulfuric acid as a one reactant. This is our first option. In the second option, we have to use initially concentrated sulfuric acid. After adding concentrated sulfuric acid, we have to use H2O. Then this our second reaction becomes an electrophilic addition reaction. This is our electrophilic addition reaction. An electrophile is hydrogen plus. In ninth organic conversion, we have bromopropane. Then we need to convert this bromopropane into 2-chloropropane. First of all, you should know that this organic conversion can be done with 3 steps. According to the last organic conversion, initially we made propene. Also in our ninth organic conversion, we have to make propene in our first step. For that, I have to use ethanol with potassium hydroxide or sodium hydroxide. We know that potassium hydroxide and sodium hydroxides are strong base. So after making propene, we have to use dilute H2SO4, and you know that this our second step becomes an electrophilic addition reaction, and the first step is an elimination reaction. Elimination compound is HBr. Now our second product is this one, this secondary alcohol, CH3CHOH and CH3. Then you can see we have to use some nucleophile for OH minus. Nucleophile should be Cl minus. Then we have to use PCl3 or PCl5. As I explained, our third step is a nucleophilic substitution reaction, and the nucleophile is Cl minus. 10th organic conversion is we have a secondary alcohol. First of all, we need to convert this secondary alcohol into propene. This is the molecular structure of propene: CH3, CH, double bond, and CH2. This one is known as propene. To make propene, you can use concentrated H2SO4, that means sulfuric acid, under 100 Celsius degree, or you can use aluminium oxide with 350 Celsius degree. After making propene, you have only one step to follow. Our second step should be we have to use hydrogen bromide. You know, hydrogen bromide is a strong acid. We have to use hydrogen bromide with peroxide medium. For peroxide, we can use this one. This comprises with 2 aryl groups like this. This peroxide can be used for this reaction. Also, this reaction happens under anti-Markovnikov rule. That means hydrogen bonds with middle carbon atom and Br bonds with this corner carbon atom. The reason for that is this carbon, this middle carbon, comprises with 1 hydrogen atom, and this corner carbon atom comprises with 2 hydrogen atoms. Also, this reaction is a electrophilic addition reaction, and the electrophile becomes hydrogen plus.